All right. There are other videos that talk about the reference angles and the coterminal angles. So if your questions are on that, those are the other two videos. Make sure you watch them as well. All right. Talk about the unit circle here just for a second. Oh, that's not the best, the most even unit circle. All right. So for this unit circle, we have quadrant 1, quadrant 2, 3, and 4. One thing about this is the order pairs on this. Man, I'm sorry. This is just not. There we go. So this is the Cartesian coordinate plane still. I guess we're not really talking about the unit circle just yet, but there are points on this plot, and how we do that. Just draw the unit circle. Not a great circle. Whatever. You guys get over it. Is these order pairs will always be written in the form of cosine, theta, sine, theta. All right. So that means cosine is my x, sine is my y. And they will determine a lot. So I guess where do I want to go from here? And I guess I should slow down for just this section. In first quadrant, my cosine is positive and my sine is positive. And since my tangent is the cosine of the sine, or sine cosine, however, if they're both positive, my tangent is also positive. In the second quadrant, my cosine is negative, right, because this is my x. My y is still positive, and then that makes my tangent negative, right, because I have one negative. Down here, my cosine is negative because it's my x. My sine is negative now because we're now below the x-axis. And I have two negatives. That makes my tangent positive. Over here, I have a positive cosine now, and I'm still below the x-axis, so I have a negative sine, and that makes my tangent negative. So if I want to scroll up to right there, in which quadrants is sine negative? Well, sine is my y, and that's going to be in quadrant 3 and 4 of what we just kind of discussed. All right, so now they want to know, identify the sign, positive or negative, for each trigonometric ratio. All right, so 179 degrees is going to be right about here somewhere, so it's in the second quadrant. Right, and if I go back down, I remember that the second quadrant, my cosine is negative. My sine is positive, so my x is negative on the left side. My y is positive, and then my tangent, since it's a combination of these, will have to be negative, because one negative, one positive means we're going to be left with a negative. Third quadrant, I could have done, if we had a third quadrant one, it would be negative, negative, positive. All right, so whatever I have written down here, where cosine is x, sine is y, it just follows the x's and the y's. It's not a big deal. All right, so now we want to evaluate each ratio without using a calculator. What this is generally going to mean is it should end up being a pretty simple fraction. All right, so excuse me. I know 210 degrees is going to be in the third quadrant. So it's going to be here somewhere because it's just past my 180, which is there, and then it's still underneath my 270, which is here. So it's the third quadrant, and it's here somewhere. All right. So I want to subtract it from 180. So third quadrant, I'm going to go ahead and I'm going to subtract the 210 by the 180, and I'm left with 30. All right. Excuse me. So 30, and then if you remember what we did previously, I think section 2 maybe, or section 1, we want to know what the sine of 30 was. Well, the sine of 30 is 1/2. So the sine of 210 is 1/2. And the reason why it's a reference angle, we kind of went and found a reference angle, is because the order pairs for the 30-degree angle is going to be the same for the 210-degree angle. So we have a sine of 1/2, or sorry, the sine of 210, which is the sine of 30, which is 1/2. But we do need to remember that we are in the third quadrant. And in the third quadrant, sine is negative. So for this, we really needed to find the reference angle, which was 30 degrees, identify the sine of 30 degrees, and then, all right, what quadrant am I in? Is it going to be positive or negative? So I'm going to scroll down to the cosine of 135. So I know cosine of 135. I know 135 is going to be here somewhere. Something like that. All right. I need to find what my reference angle is. So I'm going to go ahead and I'm going to subtract 180 and 135, and I'm left with 45. So there's my reference angle. And I need to know what the cosine of 45 degrees is. Well, that's going to be radical 2 over 2. Again, there's that chart. At the beginning of this section, I gave you a bunch of different like little cheat sheets that have all this information. The unicircle has this information. So cosine of 135 is going to be radical 2 over 2. Cosine of 45 is going to be radical 2 over 2. Now, I'm in the second quadrant, and cosine is negative in the second quadrant. So I need to make sure I add my negative sign. All right, that's the only thing that changes is the positive and negative as you go around the circle with all these reference points. All right, so we want to find the tangent of theta. If sine of theta is equal to negative 9 over 41, and cosine of theta is equal to negative 40 over 41. Now we know the tangent is opposite over adjacent. Well, another way to write tangent, if you don't know, and I believe this is, again, in those little cheat sheets I had at the beginning of this unit, I know that the tangent of theta is equal to sine over cosine. All right. Well, I know my sine is negative 9 divided by 41 divided by negative 40 over 41. And when I divide two fractions, what I'm actually doing is multiplying. All right, so I have this. These 41s cancel. I have a negative 9 over a negative 40. That's going to be a positive 940. So the tangent of theta in this scenario is going to be 940. That's because I use the formula the tangent of theta is equal to sine over cosine. I plug sine and cosine in, and I flipped and multiplied. It canceled. And if you want to use a calculator, which you're not really supposed to, you can double check yourself. I have no problem with that. You should get the same answer. All right, the terminal side of theta is in quadrant 4, so we're in quadrant 4. And cosine is 12 over 13. What is sine? For this one, I'm going to go ahead and I'm going to draw a right triangle. And the one thing when I draw a right triangle is I always want the right angle to be on the x-axis. All right, and then this would always be my theta. My theta is always there by the origin. All right, so cosine is 12 over 13, which is adjacent. This is now my adjacent side, over hypotenuse, 13. All right, so what I could do is I can do 12 squared plus x squared equals 13 squared. And then in this process, I could 144. I guess I'll just go ahead and finish it all the way out. I can solve for this other side, 169. X squared is equal to, excuse me, 25. Then x is going to be equal to 5. All right, plus or minus. So anytime you take the square root, you got to take a plus or minus. All right, so it's going to be plus or minus 5. Well, I'm in the fourth quadrant, and this is going down. This is going to be a negative 5. All right, so you do have to pay attention again where we're at. And then sine of theta is going to be opposite over hypotenuse. So it's going to be negative 5 over 13. All right, again, because we know that sine is negative in the fourth quadrant. Lots of mistakes if we forget the negative and not thinking about that. Another thing that we could do, is we could use the identity sine squared plus cosine squared squared theta, sorry, is equal to 1. All right, so we don't know what the sine squared is. So this is just sine squared theta plus 12 over 13 squared equals 1. And then I go ahead and do the square. So we have 144 over 169. I subtract that from both sides. So I can subtract the 144 over 169 from both sides. And I get sine squared theta is equal to 25 over 169. Because when you do, you do this subtraction. And if you do that, you're left with 25 over 169. And then I have to take the square root. Well, we're kind of in the same spot. So sine squared theta is equal to plus or minus 5 over 13. Then you had to choose if is it sign positive or negative. I guess there's going to be no squared here. Is it positive or negative in the fourth quadrant? Well, we know it's negative, so we know this is actually going to be negative 5, 13. So this is another way to do it. Obviously, the way I showed you is another option. They both lead to the same direction. I know this one probably initially looks more complicated, but it's kind of straightforward, I believe. This one has a few additional steps, I guess. So either's acceptable for me. I'm not going to be picky about it. All right. Okay, so we have cosine of theta is equal to negative 0.72. Now, this is one where we'll have to use, oh, sorry, the next one, I was looking ahead of 10. My apologies. We want to identify the quadrant of the terminal side of theta. All right, so we know our cosine is negative, but my sine is going to be positive. So where is cosine negative and sine positive? So the only place where cosine is negative and sine is positive is in the second quadrant. So this is the second quadrant, and that's all we needed to know. So this is saying that cosine is negative, sine is positive. Where would that be? What quadrant? Quadrant 2. Now 10, there we go. Sine of theta is equal to negative 0.8, and cosine is less than 0. So if cosine is negative, we want to find the cosine of theta. All right. So this is one where we can't do this method because we're not given a fraction. We are given just a decimal. So this is one where we have to use this formula, which actually without the fraction, it probably makes it look a little bit easier. All right, so I know my sine is negative 0.8. I still don't know what my cosine is yet, right? That's what we're solving for. I'm going to go ahead and I square this. It's going to be a positive 64. I subtract 64 from both sides. I'm not going to write it out because I'm going to run out of space. I subtract 64 from both sides. Apologize for that. That's my phone going off. Best ringtone ever. I got the 0.36. 1 minus 0.64. 1 minus 0.64 is where I got this from, just so we all are good. I square root both sides. Cosine of theta is equal to plus or minus. Anytime you take the square root of a number, you got to give me a plus or minus. It's going to be plus or minus 0.6. And since we know the cosine has to be less than 0, so it has to be negative, my answer is negative 0.6.